these two topics are completed. Now, what is that today's topic? It is the system of linear equations. System of linear equations. So, what are the two types of linear equations we are having? Non-homogeneous equations, and it is the homogeneous equations. Homogeneous equations. So what are the non-homogeneous equations and homogeneous equations? Non-homogeneous is a1x plus b1y plus c1z is equals to d1, a2x plus b2y plus c2z is equals to d2, a3x plus b3y plus c3z is equals to d3, and homogeneous a1x plus b1y c1z is equals to 0, a2x plus b2y c2z is equals to 0, a3x plus b3y plus c3z is equals to 0. See, if at least one of the d1, d2, d3 is non-zero, then it comes under a non-homogeneous. If all are the zeros, it is a homogeneous equations. So two types of linear equations, non-homogeneous and homogeneous. Then how to write this matrix form of these equations here? A1, B1, C1 matrix form, A2, B2, C2, A3, B3, C3 into XYZ is equals to D1, D2, D3 matrix form of the. So this is the matrix form of the non-homogeneous equations. Ax is equals to B. A is the coefficients matrix, X is the variable matrix, B is the constants matrix. Then coming to here, A1, B1, C1, A2, B2, C2, A3, B3, C3 into XYZ is equals to 0, 0, 0. So that is a Ax is equals to null matrix. A is the coefficients matrix, X is the variables matrix, and it is a null matrix. So these are the matrix form of the equations. So to solve these equations, we have different methods. For this one, inverse method is there. Then Cramer's rule is there. Gauss-Seidel methods, different types of methods. But for solving these two, we have to go with the, what is the name of that method? It is called the rank approach. We have to go with the rank approach only. So before going to the procedure to solve that, we should know some definitions. Consistent definition. What is consistent? Consistent definition. The system of linear equations. The system of linear equations is said to be consistent. The system of linear equations is said to be consistent if it has unique solution, unique or infinite number of solutions. Unique or infinite number of solutions. So that is a consistent definition. If it has unique means what? XYZ contains only single values. Infinite means what? XYZ, they are all expressed in terms of the arbitrary constants. Depending on the arbitrary constant, you will get the infinite number of the solutions. So like in this case, X is expressed like K, Y is equals to 1 plus K, Z is equals to 2 minus K, like that. Depending on the K value, you will get infinite number of the solutions. Unique means what? X, Y, Z contains some single values. Let us take some example 1, 2, 3. They are unique. unique and infinite, then it is called consistent. So then it is inconsistent. Next definition, inconsistent. What is the definition of inconsistent? The system of linear equations, the system of linear equations, the system of linear equations is said to be inconsistent. The system of linear equations is said to be inconsistent if it has no solution. No solution. The system of linear equations is said to be inconsistent if it has no solution. Unique solution are infinite, and here it is the no solution for inconsistent. Then coming to here, I'm going to draw some lines here. One more definition we should know. Trivial solution. What is trivial solution? Trivial solution. XYZ 0 0 0. It is called the trivial solution. Trivial solution. XYZ is 0 0 0 is called the trivial solution. So this trivial solution is associated to, yeah, listen here, the word trivial solution. Trivial solution is associated to homogeneous equations. Homogeneous equations. And homogeneous equations are always consistent. Homogeneous equations are always consistent. So remember this word, homogeneous equations are always consistent. So these are the different words: consistent, inconsistent, trivial solution. Now, see here I am going to draw some lines here. Two lines intersected like this. Two lines are parallel. Two lines are coincided like this. Two lines are coincided one upon another. See, this belongs to unique solution. Only at one point they are all intersected. This is a unique solution. And two lines there is no intersection, no solution. And two lines are overlapped each other, then it contains infinite number of solutions. Infinite number of solutions. See, if two variables equations are there, a1x plus b1y is equals to c1, a2x plus b2y is equals to c2. These two are what? These two are non-homogeneous equations in terms of the two variables x and y. In terms of two variables x and y. For unique solution, what is the condition is a1 by a2 is not equals to b1 by b2 is not equals to c1 by c2. For no solution, a1 by a2 is equals to b1 by b2. It's not equal to c1 by c2. For infinite number of solutions, a1 by a2 is equals to b1 by b2 is equals to c1 by c2. So this logic is applicable only two variables are involved. Only two variables are involved. So if there is more than two variables, three variables are involved, then we have to go with the rank approach. Three variables are involved, we have to go with the rank approach. Remember these conditions when two variables are involved. So rank approach, we have to go with the rank approach. Procedure to solve non-homogeneous equations. Procedure to solve non-homogeneous equations. First step, write matrix form of given equations. Write matrix form. Write matrix form of given equations. So let us take it is a AX is equals to B matrix form. A is the coefficients matrix, X is a variable, B is a constant. Second, take A and B augmented matrix, A and B augmented matrix. That means what? A and B in one matrix. What is the meaning of augmentation of two matrices? A and B in one matrix. Third step. Find rank of augmented matrix. A and B augmented matrix. Fourth step. If rank of augmented matrix is not equals to rank of A is one case. Rank of augmented matrix is not equal to rank of A is one case, and it is equals to rank of A another case. Rank of augmented matrix is not equal to rank of A, then it is called inconsistent. Inconsistent means what? No solution. If rank of augmented matrix equal to rank of A, and here two cases, if rank of augmented matrix equal to rank of A, that is equals to number of unknowns. Number of unknowns is one case, and second one is what? Less than number of unknowns. Less than number of unknowns. Two cases raises here. Rank of augmented matrix equal to rank of A, that is equals number of unknowns, then it contains what is the solution is called unique. In this case it contains infinite number of solutions. That is the procedure for solving what type of equations? Non-homogeneous equations. So remember this procedure. And coming to procedure for the homogeneous equations. Procedure to solve homogeneous equations. To solve homogeneous equations. So what is the thing we have to do here? Write matrix form of given equations. Write matrix form. Ax is equals to null matrix. A is called coefficients, x is the variables, that is a null matrix. Next step is find rank of A. Find rank of A. No need to take augmented matrix. Just find out rank of A is enough. Find the rank of A. Next step is if rank of A is equals to number of unknowns. If rank of A is equals to number of unknowns is one case, less than number of unknowns another case. If rank of A is equals to number of unknowns, then it contains a unique solution. That unique solution is called a trivial solution. What is a unique solution? Trivial solution. So what is the trivial solution here? 0, 0, 0 is the trivial. If rank of A is less than number of unknowns, then it contains what? Infinite number of non-trivial solutions. Infinite number of non-trivial solutions. So what is the meaning of the non-trivial? Other than zeros, non-trivial. This infinite number of non-trivial solution we are calling as a eigenvector also. There also I will explain this one. This infinite number of non-trivial solution is called the eigenvector. Eigenvector is associated to what type of equations? Homogeneous or non-homogeneous? Means eigenvector is associated with the homogeneous equations. Remember this concept. So these are the procedures to solve the homogeneous and non-homogeneous equations. Hope these all procedures are cleared. So what are the things you have studied here? Types of matrices, system complete. What are the homogeneous and non-homogeneous equations? Consistent definition, unique or infinite, inconsistent, no solution. Trivial solution means what? Zero solution. Two lines in two variables. When two variables are involved, there is no need of rank approach. Remember that, no need of rank approach. When three variables are involved, we have to go with the rank approach. So this is a procedure to solve the non-homogeneous and homogeneous equations, right? Now let us solve some questions here. For what values of alpha and beta, the following simultaneous equations have infinite number of the solutions? For what values of, this is a previous gate question, 2 marks bit. The solution here as follows. What type of equations they are called? They are non-homogeneous equations. As all of you know, non-homogeneous d1, d2, d3 are there. So first of all, we have to make what is its augmented matrix here. AB augmented matrix. AB augmented matrix. What is the A matrix here? 1, 1, 1, 1, 3, 3, 1, 2 alpha, 5, 9 beta. So we have to we have to find the rank of this matrix here. Rank of this matrix. So how to find the rank of this matrix here? What is the order of this matrix? The order of the matrix is 3 by 4. 3 by 4. Maximum rank of augmented matrix. Rank of augmented matrix is less than or equal to 3. All of you know. What is the maximum rank of this is expected is the 3. Rank 4 is not possible here. So to find out the rank of this, what is the logic we have to do? We have to convert it into the echelon form. Remember? So this type of questions are for the 2 marks bits. They are all 2 marks bits. We have to reduce it into a echelon form. What is the echelon form means? You see here, first to select 3 by 3 square matrix. All elements below principal diagonal. All elements below principal diagonal we have to convert into 0. So means this 1, 1, 2 we have to convert into 0. For that, what are the operations required? Keep the first row constant row. Keep the first row constant row and make these two elements zeros. R2 implies R2 minus R1. R3 implies R3 minus R1. With this, this given matrices, augment matrix reduces to what? These two are the zeros. R2 minus R1, this is 2 and it is a 4. R3 minus R1. So any confusions? Yeah. See, R3 minus R1, what is the R3 minus R1 here? If you are observing, R3 minus R1 is what? This is the 2 minus 1 is 1, alpha minus 1, beta minus 5. Beta minus 5. Yeah, coming to next. So what is the next one here? This 1 also we have to reduce. The second row is divisible by 2. R2 implies R2 by 2. 1, 1, 1, 5. So screen is cleared, all of you. Just to confirm the screen is cleared. Screen is appearing clear. This is a 0, 1, 1, 2. R2 is divided by 2. 0, 1, alpha minus 1, beta minus 5. Right, thank you. Yeah. So then what is the next logic is this 1 is, we have to reduce this 1 into the 0. What is the operation is required here? R3 implies R3 minus R2. We have to relate the third row and second row here. Third row, second row. Don't relate the third row with the first row. Third row, first row should not be related here because this element will be disturbed. We should not disturb these elements. Only our target is this should be converted into 0. For that we are using this operation. What is the result here? 1, 1, 1, 5, 0, 1, 1, 2, 0, 0, alpha minus 1, alpha minus 2, beta minus 7. So after reducing up to here, this is now in the echelon form. This is an echelon form. But what the question is asking? Infinite number of solutions. For what values of that alpha and beta it contains infinite number of the solutions. For infinite number of solutions, what is the logic we should know? Rank of augmented matrix is equals to rank of A. Both should be equal. less than number of unknowns. This should be cleared. Both the ranks should be equal, less than number of unknowns. But how many unknowns we are having here? X, Y, Z. X, Y, Z, 3 unknowns are there. But to satisfy the infinite number of solutions, both the ranks should be equal, less than number of unknowns means what? Less than 3 rank is required. So when you will get the rank is less than 3, alpha equal to 2, beta 7. If alpha to beta 7, what happens here? If alpha to beta equal to 7, this last row becomes a 0 row. Last row becomes a 0 row. Then what is that? Only 2 non-zero rows left. In that case, what is the rank of augmented matrix? Rank of augmented matrix, and this is the rank of A portion. Both the ranks will be 2 in this case. If alpha equal to 2, beta equal to 7, last row becomes a 0 row, and both the ranks are equal to 2, that is less than number of unknowns. For infinite number of solutions, what is the correct answer? Option C is the correct answer. What are the values are required? Alpha to beta 7, last row becomes a 0 row, overall rank becomes 2, and rank of A is also 2. So that we have to clear. Yeah. For this we should know the procedure with this one. This procedure is required. Rank of augmented matrix equal to rank of A, it is equal less than number of unknowns, infinite number of the solutions. If both the ranks are equal to number of unknowns, then it contains a unique solution. Yeah, this question is clear to all of you. Everybody understood? Yeah, this is clear to all of you. Yes. Yeah, any confusion clear? All of you understood this question, right? Let us move to our next question. See here, one more thing. For what values of alpha and beta, then it contains the unique solution. What values of alpha and beta it contains unique solution is alpha not equal to 2. If alpha not equal to 2, rank of A is the 3. Alpha not equal to 2, rank of A is the 3, and beta can be any value. No need of beta. Beta can be any value. If alpha not equal to 2, rank of A is the 3. Obviously rank of augmented also becomes 3. Both the ranks becomes 3. That is equals number of unknowns. Then for unique solution, which option? Alpha not equal to 2, beta it can be any value. For unique solution, alpha not equal to 2, beta can be any value. Beta can be any value. That point you have to remember for unique solution. For no solution, what is this value? This is 0 and it should not be 0. For no solution, alpha equal to 2, beta not equal to 7. Alpha equal to 2, beta not equal to 7. This is for no solution. This option is for no solution. If alpha equal to 2, what happens? Concentrate please all of you. Alpha equal to 2, then rank of A becomes what? 2. But beta not equal to 7, rank of augmented matrix is the 3. Alpha equal to 2, beta not equal to 7. Alpha equal to 2, rank of A is 2. But beta not equal to 7, rank of augmented matrix is 3. Both the ranks are not equal, then it contains the no solutions. In this single question, I discussed 3 questions here. Our answer is completed with alpha equal to 2, beta equal to 7. Along with that, I discussed for the unique solution, no solution, what are the alpha and beta also. So concentrate, this type of questions are 2 marks bits. Next question. The system of equations 2 minus 2, 1 minus 1, x1, x2 equal to 0, 0 has, first of all, what type of equations they are? Can you guess what type of equations they are? Homogeneous or non-homogeneous? Yes, tell me, these equations are homogeneous or non-homogeneous? Yes. These are the homogeneous equations. Very good. Homogeneous equations. How to confirm homogeneous equations? Right hand side are the 0 zeros are there. What you have to do here? Just find out the rank of A is enough. What is A here? 2 minus 2, 1 minus 2. This is a 1 minus 1. Yeah, this is our A. Find the rank of A. What is the rank of A here? If you calculate the determinant of A, what is the result? Minus 2 plus 2 equal to 0. Determinant of A is 0 means what? Rank of A is equals to 1 in this case. Rank of A, it's not the 2. Rank of A equal to 1. Yeah, very good. Rank of A is equals to 1. Then it contains what? What is the answer it contains now? Yeah, rank of A is 1, then it is not the unique solution. It contains what type of solution? Infinite number of non-trivial solutions. Infinite number of non-trivial solution is the answer. If rank of A equal to 2, what happens here? Unique solution. There is no, see, B never possible. You will not get any B also. B we cannot get. Yeah. Yeah, coming to now, as all of you know, B never possible in the homogeneous equations, because homogeneous equations are always consistent. No solution ranges, no solution is not applicable in the homogeneous equations. This equation contains how many solutions? Infinite number of non-trivial solutions. Here I am going to explain how infinite number of non-trivial solutions. If you will write the equations here, 2x1 minus 2x2 is equals to 0. From this, x1 equal to x2. See, two unknowns are there. For solving two unknowns, we need two equations, but there is only one equation is there. So you can equate x1 by, this is x1 by 1, x2 by 1 equal to k. What is x1 is k, x2 is also k. So what is the result of x1, x2 we are getting here? K comma k, kk. K here, if you put k value is 1, k value is 1, what is the answer you are getting? 1 1. K value is 2, 2 2. Like that, depending on the k value, you will get infinite number of non-trivial. Remember this word, non-trivial means what? Other than zeros. Now you tell me which value of the k is not applicable here. Which value of the k is not applicable in this case? It is applicable for all values of the k except one value of the k. Which value of the k is not applicable? Anybody? So one value of the k is not applicable. Which value of the k is not applicable? Yeah. Yes, yes. Very good, very good. Yeah, 0. All of you know, k is equals to 0 is not applicable except k equal to 0. For all values, it contains infinite number of the non-trivial. Remember that, infinite number of non-trivial solution. If you keep the k value 0, what is the answer? It is a unique solution, trivial solution. So this is clear to all of you. Yeah. Yeah, coming to our next question here. The value of q for which 236q xy equal to 0 0 has non-trivial solution. Yeah. First of all, what type of equations they are? They are homogeneous equations. Homogeneous equations. Remember, these are the homogeneous equations. For homogeneous equations, only we have to calculate the rank of A is enough. He is asking non-trivial solutions. Non-trivial means solution means what? Infinite number of non-trivial solutions. For non-trivial solutions, what is the rank of A? Non-trivial solution rank of A, it should not be equal to 2. Rank of A less than number of unknowns. Rank of A is less than number of unknowns is required. Less than number of unknowns. For that, what is that? Determinant of A should be equal to 0. If determinant of A is 0, what is the rank? It becomes 1. Determinant of A is 0. 2, 3, 6q. Determinant equal to 0. You are all understanding. Determinant of A equal to 0, then only rank of A it becomes 1. Rank of A is 1. It's not the 2. Yeah, what is the result of this one here? 2 into q. 2q minus 18. Q is equals to 9 is the answer. Q equal to 9. So very good. Q equal to 9 is the answer. Okay, very good. See, what is the condition we are using? Determinant of A equal to 0. First of all, we have to 2 marks from this. Whenever they are asking this type of questions, so 2 marks weightage generally. So So what type of equations? First of all, we have to identify whether they are homogeneous or non-homogeneous. In this case, it is a homogeneous equation. Hope everybody understood this solution, right? Yeah, next question here. Yeah, the system of equations has, what is the answer? Yeah. Can anybody guess what is the answer? The system of equations has. See, first of all, what type of equations? They are homogeneous or non-homogeneous? They are homogeneous equations. For homogeneous equations, we have to calculate the what is the rank of A. A is what? 2, 1, 1, 0, 1, minus 1, 1, 1, 0. This is a matrix A. What is the rank of this one? We can guess rank of A is directly 2 here. Directly 2. So how directly to here? There is a relation between the columns here. Observe. C1 minus C2 is equals to C3. C1 minus C2 equal to C3. C1 minus C2 equal to C3. C1 minus C2 equal to C3. If there is a relations between the rows or columns, then determinant of A directly becomes 0. Remember this point? Determinant of A is directly 0. In the determinant properties I explained. If there is a relation between the rows or columns, determinant becomes 0. If this determinant becomes 0, then we can say directly rank of A will not be 3. So then obviously what is the rank of this one? It becomes 2 here. If rank of A is 2, then it is a less than number of unknowns. Rank of A is less than number of unknowns. What is the answer directly? Infinite number of the non-trivial solutions. Infinite number of the non-trivial solutions. So this is clear to all of you. There is no much complexity. Direct straight question. The only thing is what we have to identify, it is a homogeneous or non-homogeneous equations, right? So this is clear to all of you. Let us go to our next question here. The system of equations has option A, unique, infinite, no solution, none of this. First of all, what type of equations they are? First of all, what type of equations they are? We should know what type of equations they are. Non-homogeneous equations. They are non-homogeneous. So last 2-3 questions are homogeneous. First question is non-homogeneous. Now it is a non-homogeneous. For non-homogeneous equations, what you have to do? Take the AB augmented matrix. 1 minus 1 1, 3 minus 1 2, 3 1 1. We are bringing that B also inside augmented matrix. 2 minus, this is called AB augmented matrix. So what is the maximum rank of this AB augmented matrix is expected? Rank of augmented matrix less than or equal to 3. What is the 3 by 3 is maximum square matrix is available. There is no 4 by 4. Rank of augmented matrix is less than or equal to 3. So already I explained what is the method we have to apply. Echelon form to find the rank of this. We have to go with the echelon approach. Definitely we have to go with the echelon approach. Echelon approach means what? All this matrix. First square matrix 3 by 3 we have to reduce into echelon form. All elements below principal diagonal zeros. 1 minus 1 1 below this, all elements should be zeros. For that, what are the operations required here? First one, yeah, R2 implies R2 minus 3R1. R2 minus 3R1. R3 implies R3 minus 3R1. With that, it changes to what? 1 minus 1 1 2. First row is as it is. These two are the zeros with these operations. What is the R2 minus 3R1? Minus 1 plus 3. R2 minus 3R1. Minus 1 plus 3. This is 2. This is what? 2 minus 3. Minus 1. Minus 6 minus 6. Minus 12. The next R3 minus 3R1. 1 plus 3. 4. R3 minus 3R1, 1 minus 3, minus 2. R3 minus 3R1, minus 18, minus 6, minus 24. So this is the result after applying these two operations. Then what is the next step here? One more element is pending. This 4 should be converted 0. So without wasting the time in the exam hall, without wasting the time, after applying this operation, just immediate what is the next thing we have to do is check these two rows are proportional or not. These two rows are proportional. ఇవి రెండు జాగ్రత్తగా చెక్ చేసుకోండి మీరు. ఈ రెండు కూడా మనకి ప్రపోర్షనల్ అనిపిస్తే ఏం చేయాలి మనం? If they are appearing proportional, yes or not, both are appearing proportional, both are appearing proportional, directly you can write this is what 1 minus 1 1 2 first row, second row is what 0 2 minus 1 minus 12, straight away you write the last row as a 0 row. See how the last row to 0 row, r3 minus 2 r2, r3 minus 2 r2, r3 minus 2 r2, r3 minus 2 r2, that makes that last row as a 0 row. Actually one step you have to apply r3 minus 2 r2. If you have enough practice, there is no need to write all these things, directly write them straight away. So overall how many non-zero rows we are having? 2 non-zero rows. That means rank of augmented matrix is 2, rank of A is also 2, rank of augmented matrix is 2, rank of A is also 2. Some of you are thinking so what is the A's are here? Yeah, observe here, this is our A portion, this is our A portion. What is the rank of the A portion? A portion rank is also 2, overall rank also 2, both the ranks are equal. Rank of augmented matrix, rank of A, both are equal to 2, which is less than number of unknowns, less than number of unknowns. So what is your answer? Both the ranks are equal to 2, less than number of unknowns. What is the answer you are going to write? What is the answer? Is it unique, infinite, no solution, none of these? What is the answer? So I am waiting for your answer. Both the ranks are equal to 2, less than number of unknowns. If the rank is less than number of unknowns, what type of answer you will get? Unique or infinite, no solution. Yes? Which option? Unique, infinite, no solution. So what type of equation they are all? First of all, non-homogeneous. What is the answer you will get here? Infinite number of the solutions. Infinite. Both the ranks are 2, less than number of unknowns. Hope everybody understood. This solution is cleared. All of you understood. So clear to all, please confirm. So let us go to our next question here. Yeah, this is a very interesting question, recent gate paper. So the set of equations, the set of equations x plus y plus z equal to 1, ax minus ay plus 3z equal to 5, 5x minus 3y plus az equal to 6 has infinite number of solutions. If a is equals to what? For what value of the a? It contains infinite number of solutions. First of all, what type of equations they are? Non-homogeneous. They are non-homogeneous equations. For non-homogeneous equations, we have to calculate rank of augmented matrix. 1 1 1 1, a minus a 3 5, 5 minus 3 a 6. What the question is asking? Infinite number of solutions. One thing you remember, for infinite number of solutions, you will find the relation between the rows. Relation between the rows available. Relation between rows is available, definitely is available. If there is a infinite number of solution, you will find the relation between the rows. For what value of the a, there is a relation between the rows, like r1 plus r2 is r3, r1 plus r2 is r3, like that. Any, for what value of the a, can you guess? Anybody, can you guess? See here, 1 plus 5 is 6, 1 plus 5 is 6, 1 plus 3 is what? 4, 1 plus 3 is 4. whether this 4 is satisfying or not. 1 minus 4 is minus 3. 1 plus 4 is 5. What is our answer? 4 is the answer. Directly this trial and error. See, you will find what is the question is asking infinite number of the solutions. For infinite number of the solution, you will find definitely what is the condition for infinite number of the solutions. Rank of augmented matrix is equal to rank of A. It should be 2 less than number of unknowns that is required. Less than number of unknowns. How many unknowns are there? 3 unknowns. This order is 3 by 4. This condition is required. For what value of the you will get this condition? The answer is the 4 is the correct answer. A is equals to 4 is the correct answer. Hope everybody understood. The solution is clear to all of you. Please confirm. Everybody understood? It's an interesting question. Keep the star mark for this question. Yeah. Consider the following system of linear equations here. The value of k for which there are infinite number of the solutions. Following system of linear equations. What type of equations they are? They are non-homogeneous equations. Non-homogeneous equations. How many variables are involved here? Only 2 variables are involved. Only 2 variables. If only 2 variables are involved, what is the condition? Condition for what? Infinite number of the solutions. A1 by A2 is equals to B1 by B2 is not equal to C1 by C2. Remember this condition. A1x plus B1y is equals to C1. A2x plus B2y is equals to C2. Okay. This is the condition. What is A1 value here? Observe here. A1 is 3. A2 is what? K. 3 by K. B1 by B2. 2K. For what values of the K? Yes? Any confusions? Okay. 2K by, this is what? 2K by 6. Yeah, simplify this one here. Yeah, right. Option A. Yeah, here it is equals what? K square equal to 9. K is equals to. K square is, yeah, A1 by A2 equal to, sorry, for infinite number of solutions, na? Sorry, this condition is what? For infinite number of solutions. Yeah, this is wrong here. This is also equal symbol. Take the equal symbol. This is also here equal symbol. This is also equal symbol. Means 2k by 6 is equals to what? 2k by 6 is equals to minus 2 by 2. For that one, k is equals to what is the result? 3 by k is equals to minus 1. K is equals to minus 3. A1 by A2 equal to B1 by B2 equal to C1 by C2 we have to use. 3 by k is equals to minus 1. K is equals to minus 3. Option C is the correct answer. Some of you responded option A. Option C is the correct answer. Please correct your answer. Is asking infinite number of solutions. For infinite number of solutions, all are equal symbol. If this is the not equal symbol, no solution. If these both are not equal, what is the, that is the unique solution. Yeah, with this is clear to all of you. Everybody understood? Yeah, coming to next question. See, consider the matrix K, 2K, K square minus K, K square and vector x1, x2. The number of distinct real values of the K for which Ax equal to 0 has infinite number of solutions. Ax equal to 0 has infinite number of solutions. So Ax is equals to 0 means what? What type of equations? They are homogeneous. They are homogeneous equations. For homogeneous equations, infinite number of solution, what is the condition is required? Rank of A is less than number of unknowns. Rank of A is less than number of unknowns. For that, determinant of A is equals to 0. Determinant of K, 2K, K square minus K, K square. equal to 0. K cube minus 2k into k square minus k equal to 0. K cube minus 2k cube plus 2k square is equals to 0. From this 2k square minus k cube equal to 0. K square you take common, 2 minus k equal to 0. What are the values we are getting? K is equals to 0, 0, 2. K is equals to 0, 0, 2. What the question is asking here, the number of distinct real values of the k for which Ax has infinite number of solutions. The answer is how many distinct values we have? Two distinct values, 0 and 2, 0 and 2, two distinct values, 2 is the answer. Hope this is clear to all of you. What type of question it is? A homogeneous equations. Yeah, everybody understood. Yeah, let us go to our next question. Yeah, this question you try, x1 plus 2x2 equal to b1, 2x1, this is a 4x2 equal to b2, 2020 question. 7, 3x1 plus 7x2 b3, 3x1 plus 9x2 equal to b4. Which one of the following conditions ensures that a solution exists for the above? You try this question, any confusions I'll explain in the next class also. So your answer here, 6b1 D option, check once. Any confusions is there, I'll explain in the next class also. Check this question. Yeah, coming to next question here, the solution to the system of equations. Yesterday also I explained, I have given some questions in the previous class, so try to solve them. Right, the solution to the system of equations, just take it as a 2x plus 5y equal to 2 minus 4x plus 3y equal to minus 30. Cross check, just trial and error method apply. Here trial and error method you apply, what is the answer you are going to get? Yeah, 2 into 6 minus 10, this minus 14, this is what, 4 into 6 24, this is what, minus 6. Option D satisfies. Just trial and error, no need to do anything. Write the two equations, check the trial and error, D option satisfies directly. No need to take any much analysis for this one, directly trial and error. Yes, this question also you can try, no problem. The system of equations, what type of equations they are? X plus 2y plus 4z equal to 2, 4x plus 3y plus z equal to 5, 3x plus 2y plus 3z equal to 1. What type of equations? They are non-homogeneous equations. For non-homogeneous equations, what you have to do here? We have to take the AB augmented matrix 1, 2, 4, 2, 4, 3, 1, 5, 3, 2, 3, 1 like this. We have to take like this, and the same approach, all elements below principal diagonal zeros. For that, what is the operation? R2 implies R2 minus 4R1, R2 minus 4R1, R3 implies R3 minus 3R1. So that makes these two elements are the zeros. What is the result we are going to get? 1, 2, 4, 2. These two elements are the zeros. R2 minus 4R1, 3 minus 8. 3 minus 8 minus 5. 1 minus 16 minus 15. 5 minus, this is what, R2, 5 minus 8 minus 3. The next is what here? R3 minus 2, 3R1. 2 minus 9. Sorry, 2 minus R3 minus 3R1. 2 minus 6. 2 minus 6 minus 4. This is what here? R3 minus 3R1. 3 minus 12. 3 minus 12 minus 9, and this is what, 1 minus 6 minus 5. So if you observe here, so these two rows are not proportional. These two are not proportional. So what is the next operation is required? Minus 4 is required to 0. Minus 4 you have to convert into the 0. R3 implies 5R3 minus 4. 5R3 minus 4R2. This operation it makes 1, 2, 4, 2, 0 minus 5 minus 15 minus 3. This is 0, 0. If you apply for 5R3 minus 4R2, 5R3 minus 4R2. What is the 5 into R3? It is a minus 45 and it is a plus 60. Some constant you will get here. Some constant other than zeros. Here also you will get some constant other than zeros. No need to calculate exactly what is the value. No need. Now what is the answer? Overall rank. Overall rank of this matrix 3 by 4. What is the overall rank here? Rank of augmented matrix is the 3, rank of A is the 3. Both the ranks are equal. Both the ranks are equal, that is equals to number of unknowns. Then what type of solution it contains? Unique solution is the answer. See here, there is no need to calculate exactly what are the values also. Just you're all understanding this value. These two values, just confirm if they are constants. Both the ranks are 3 and 3, which is equal to number of unknowns. Then it contains the unique solution. Hope all of you understood. This question is clear to all of you. Yes. Everybody is understanding. Any confusion, please clear. So all of you confirm understanding or not? System of linear equations, very interesting, important topic. Yeah. This question all of you try. This question all of you try later. 4 equations are there in terms of the 3 variables. This question is a 2014 previous gate question. Try. You can try yourself. You'll get the answer. Yeah, this question also x plus 2y plus z equal to 4, 2x plus y plus 2z equal to 5, x minus y plus z equal to 1. The system of algebraic equations given above has unique solution, only 2 solutions, infinite number of the solutions. So yeah, what type of equations they are? They are called, what type of equations? They are called non-homogeneous equations. They are non-homogeneous. For the non-homogeneous, take the AB augmented. You can try simply this question also. 1 2 1 4, 2 1 2 5, 1 minus 1 1 1. See, to reduce it to the echelon form, what are the operations required? R2 implies R2 minus 2R1. This 2 and 1 we have to convert into the 0. R3 implies what? R3 minus R1. So this makes that matrix. This makes the matrix reduces into what? 1 2 1 4. These two are the zeros. R2 minus 2R1. This is what? 1 minus 4 minus 3 minus 3. 2 minus 2 1 2 5. R2 minus 2R1. What is the result of this one here? R2 minus 2 minus, this is what? 2 minus 4 minus 2. 2 minus 2 is what? This is 0. Then it is what here? R2 5 minus 8. 5 minus 8, it is a minus 3. Then this result is what? R3 minus R1 minus 3. This is what? 0 minus 3. These two are rows are the proportional rows. Definitely you can confirm the last row is a 0 row. Then what type of solution? It is a infinite number of solutions. You no need to wait much time in the exam. Whenever you will find last 2 rows are the same rows, last row becomes a 0 row. Then rank of augmented matrix becomes what? Rank of augmented matrix is 2. Rank of A is also 2. Both are equal. Less than number of unknowns. Straight away answer. Infinite number of the solutions. So this is clear to all of you. This type of questions are 2 marks bit. See, a little bit speed also required in the GATE exam hall. Accuracy, speed both are required. So don't be very slow. Some speed is required and also accuracy required. Only with practice. Practicing enough number of problems, you will get some confidence and accuracy also. Yeah, this question you try. Already we have done this type of question also. Infinite number of solutions. In the beginning we have done this question. 2 1 1 0 1 minus 1 1 1 0. This question we have done already in the beginning of today's class. X1 x2 x3. This is second or third question somewhere. We have discussed this is a homogeneous equations, infinite number of solutions. So what is the relation? I explained C1 minus C2 equal to C3. That makes the rank of A. What is the rank of A here? 2 less than number of unknowns. Infinite number of solutions. Yeah, similar kind of questions. First question, whatever the first question we have done, similar type. The system has what? For what values of the no solution is asking. For what values of the lambda and mu, the system has no solution. Lambda and mu. Can you guess what is the answer? Already explained logic in the first question. Anybody? A, B, C, D, which option is correct? Can you guess? This type of question already I discussed as first question in the beginning. Yeah, try to guess what is the answer. A, B, C, D, which option? Yes, for no solution, you will find definitely option B. This is already explained, this is for infinite. This is for no solution. Go through the procedure for solving the equation, you will get the answer, right? Yeah. This question, the following system of equations will not have unique solution. For what value of the k? You can try this question easily, you will get the answer. No problem. For what value of the k? The system will not have unique solution. Yeah, what type of equation? They are non-homogeneous equations. 1, 1, 1, 3, 1, 2, 3, 4, 1, 4, k, 6. So what is the maximum rank of this augmented matrix is required less than or equal to 3? Right, R2 implies echelon form. R2 implies R2 minus R1. R3 implies R3 minus R1. This reduces the equations. Matrix into 1, 1, 1, 3. These two are the zeros. 1, 2 minus 1, 3 minus 1, 1, R3 minus R1, 4 minus. This is 3, K minus 1, 3. Yeah, still one element is pending. This 3 should be reduced into 0. For that, what is the operation is required? R3 implies R3 minus 3R2. R3 minus 3R2. That makes the result as 1, 1, 1, 3. These two are the zeros. And 1, 2, 1, 0. R3 minus K minus 1 minus 6. K minus 7. 3 minus 3, 0. What the question is asking? For what value? The following system of equations will not have unique solution. For what value of the k? For what value of the k? K is equals to 7. If k is equals to 7, what happens here? If k is equals to 7, this last row becomes a 0 row. Then rank of augmented matrix is equals to rank of A. Both becomes 2 less than number of unknowns. Then it contains infinite number of solutions. What the question is asking? Will not have unique solution. For what value of the k? K is equals to 7 is the correct answer. So all of you understood, this question is also cleared. Yeah. This you try later. The following system of equations, 1, 2, 3 equations are given as unique solution. The only possible value of alpha. What is the only possible value of the alpha? You try this question later. Yeah, what is the answer? It is a D option is going to become a correct answer. Any real number other than 5. Is asking what for what solution? Unique solution. The following system of equations as unique solution, the only possible value of the alpha. It's also previous gate question. Yeah. And next, this. For what value of A, if any, the following system of equations in XYZ have a solution. 3 equations are given. What type of equations they are? Non-homogeneous equations. Non-homogeneous equations. The following system of equations for what value of A, any, will the following system of equations have a solution? Yeah, you can take this this equation I am selecting first. This is second, third. You can select any order, no problem. 1, 1, 1, 4. This I am selecting as first, and for our convenience, 2, 3, 0, 4. 1, 2, minus 1 A. Any arbitrary constant is there, keep it is the last row. What is the operation is required? R2 implies R2 minus 2R1. R3 implies R3 minus R1. This reduces 1, 1, 1, 4. These two are the zeros. R2 minus 2R1, 3 minus 2, 1. Minus 2, 4 minus, this is 4 minus 8 minus 4. What is the result of this one? R3 minus R1, 1. R3 minus R1 minus 2. And it is what? A minus 4. A minus 4. See here 1, 1, 1, 4, 0, 1, minus 2, minus 4, 0, 1, minus 2, A minus 4. So what the question is asking, for what value of the have a solution. See, if you put a is equals to 0, what happens here? A is equals to 0. These last two rows, second row, third row becomes a proportional. Both are same rows. Both are same rows. Then what happens here? 1, 1, 1, 4. 0, 1, minus 2, minus 4. Last row becomes definitely 0 row. For A is equals to 0. Then both the ranks are what? Both the ranks are equal. Rank of augmented matrix, rank of A, both are equal to which contains what? Infinite number of the solutions. What is the value of the A? A is equals to 0 is the answer. So all of you are understanding what the style of questions they are asking here. So there are all the different types of questions we are having. Yeah. With this system of linear equations also completed. Everybody understood system of linear equations also completed. Right. So till now three topics are completed. Types of matrices, rank, system of linear equations completed. Next, what is our next topic is the characteristic matrix. So hope all of you understood the system of linear equations. Once again go through that videos and PDFs also. 1-2 questions I given work for you. They are also previous gate. Next, characteristic matrix. What is the next definition? Characteristic matrix. Characteristic matrix. Characteristic matrix of square matrix A. Characteristic matrix of square matrix A. Characteristic matrix of square matrix A is A minus lambda I. Characteristic matrix of square matrix A is the A minus lambda I. What is the I? I is a unit matrix. I is unit matrix of order same as A. Lambda is the parameter. Lambda is the parameter. Lambda is the parameter called, or the lambda is the parameter called eigenvalue. So that is a characteristic matrix. Lambda is a parameter called eigenvalue. Then characteristic equation. What is the definition of characteristic equation? So last topic, all of you understood last topic, system of linear equations. Everybody understood last equations? So please confirm all of you. Last topic, very interesting, compulsory type, system of linear equations. Hope everybody understood. All of you send your messages. All of you understood. Three topics, whatever three topics are completed, all the three are very, very important. Not only in the GATE and it's further in your MTech also. Characteristic equation. What is the definition of characteristic equation? Determinant of A minus lambda I is equals to 0. Determinant of A minus lambda equal to 0 is called the characteristic equation. Yeah. Example, if you are taking lambda square minus 3 lambda plus 2 equal to 0, that is a characteristic equation. And this lambda is called the eigenvalue. What are the roots here? 1 comma 2. 1 comma 2 are the roots. 1 comma 2 are the roots of the equation. Yes, they are called the eigenvalues, characteristic equation. Yeah. So now what is the next definition? Eigenvalue. Eigenvalue, what is another name of the eigenvalue is called eigenvalue, another name is characteristic root. Characteristic root. Characteristic root. Another name is what? Latent root. Different names are there. Eigenvalue, characteristic root, latent root, different names are there. Yes. What's its definition? The root of characteristic equation. The root of characteristic equation. The root of characteristic equation is called eigenvalue. Is called eigenvalue. The root of characteristic equation is called eigenvalue. So that is about eigenvalue. Another name is the characteristic root, latent root. Now it is eigenvector. What is the definition of eigenvector? Very, very important. Eigenvalues, eigenvectors also very, very important. Yeah. Eigenvalues and eigenvectors. Any confusions, feel free clear the doubts. See, eigenvalues, eigenvectors also very, very important. One of the definite type of topic. Definitely you can expect a minimum 1 mark from the eigenvalues, eigenvectors also. Eigenvector, what is the definition? The infinite number of non-trivial solution. The infinite number of non-trivial solution. The infinite number of non-trivial solution of homogeneous equation. A minus lambda I into x is equals to 0. The infinite number of non-trivial solution of homogeneous equation. As already explained, this eigenvector is associated to homogeneous equations. The same point I am raising here also. The infinite number of non-trivial solution of the homogeneous equation. This x is called, what is this x is called here? Yeah, this x is called, this x is the eigenvector. X is the eigenvector. So when this is actually a minus lambda x equal to 0 is what? It is a homogeneous equation. This is a homogeneous equation. And this capital X is going to become an eigenvector. When this capital X is the eigenvector, remember, eigenvector, it is a non-trivial solution. It is a non-trivial solution. Remember this, non-trivial solution means other than zeros. Eigenvector never be null vector. Eigenvector never be null vector. So it is a homogeneous equation. Listen here. When capital X is a trivial solution, capital X is the trivial solution. Capital X is trivial solution. When it is going to become a trivial solution, listen here. Capital X is trivial solution. Trivial solution means what? 0, 0, 0. Capital X is trivial solution if rank of A minus lambda I equal to number of unknowns. I see here it is not the new concept. Whatever the procedure I explained in the homogeneous, the same logic we are applying here. If rank of A minus lambda equal to number of unknowns, then what is a capital X? It is a trivial solution, 0, 0, 0. If rank of A minus lambda I less than number of unknowns, then what is the capital X here? This is called the eigenvector. This is very, very important point. So eigenvector, this point is very, very important definition. For when this x is going to become eigenvector, rank of A minus lambda I is less than number of unknowns. But when it is the rank of A minus lambda is less than number of unknowns, if determinant of A minus lambda is equals to 0, if determinant of A minus lambda equal to 0, then the rank of A minus lambda is less than number of unknowns, then only capital X is the eigenvector. So now from this equation A minus lambda I x is equals to 0, What are the further equations we are going to derive? A into x is ax. A into x is ax minus lambda. I into x is, what is I into x? Unit matrix into x is x. Ax minus lambda x, ax minus lambda x equal to 0. Then ax is going to become a lambda x. Very important. Ax is equals to lambda x. Very, very important. So many gate questions on this formula. What is A is called? A is a square matrix. X is the eigenvector. Lambda is called the lambda is the eigenvalue. So now, as all of you know, Ax is equals to lambda x. Then if you multiply A again both the side, A into Ax is equals to A into lambda x. Observe this explanation clearly. A into Ax is what? A square x. This lambda keep aside, lambda into Ax. Lambda into Ax. What is Ax again? Ax equal to lambda x. Lambda into lambda x. A square x is equals to lambda square x. What happened whenever we are multiplying both the side? What is the result? We are getting a square x equal to lambda square x. Again, if you multiply both the side with a cube x is equals to lambda square into ax. What is ax again? Lambda x. Then it is going to become a lambda cube x. A cube x is equals to lambda cube x. In the same way, a power of nx is equals to lambda power of nx. This is a very, very important point. See here, what is eigenvalue? Eigenvalue of a power n is lambda power of n. Remember this formula. Eigenvalue of a power of n is lambda power of n. But eigenvector of eigenvector of a power of n is what again? X only. See here, this is very, very important property. If x is eigenvector, if x is eigenvector of a, if x is eigenvector of a, then x is eigenvector of a power of n also. For a and a power of n, eigenvector remains same. Eigenvalue only changes. Eigenvalue only changes. Okay, this is clear to all of you. Everybody is understanding? Yeah, coming to next. Now properties of eigenvalues and eigenvectors. We have very, very important properties of eigenvalues and eigenvectors. Properties of eigenvalues and eigenvectors. Properties of. So this is very, very interesting, important topic. Concentrate. Eigenvalues and eigenvectors, very, very important. See, properties of eigenvalues and eigenvectors. Properties of eigenvalues. Properties of eigenvalues and eigenvectors. First one, eigenvector never be null vector. Already I told you, eigenvector is a non-trivial solution. Eigenvector never be null vector. Eigenvector never be null vector. Eigenvector is always non-trivial solution. Second, eigenvector never be unique. As I told you already, eigenvector is a infinite number of non-trivial solution. Eigenvector never be unique. Eigenvector always expressed in terms of the k. Third, every eigenvector corresponds to its own eigenvalue, its own eigenvalue. Fourth, every eigenvector corresponds to its own eigenvalue. Means what? For every eigenvalue you will get some eigenvector. Next, eigenvectors of symmetric matrix, eigenvectors of symmetric matrix. This is also very important point. Eigenvectors of symmetric matrix are always orthogonal. See, if it is a 3 by 3 symmetric matrix, let us take 1, 2, 3, 2, 3, 4, 5, 5, 6. This is a symmetric matrix. Let us take how many eigen values are available, 3 eigenvalues and corresponding eigenvectors. x1, x2, x3, they are the eigenvectors. x1, x2, x3 are the eigenvectors corresponding to the eigenvalues lambda 1, lambda 2, lambda 3. You will find 3 eigenvalues lambda 1, lambda 2, lambda 3 for their corresponding eigenvectors. And he is saying that their eigenvectors are orthogonal. What does it mean? x1 transpose into x2 is equals to 0. x2 transpose into x3 equal to 0. x3 transpose into x1 equal to 0. 3 eigenvectors of orthogonal. What type of matrix it is? Symmetric matrix are always orthogonal. That is a fourth property, very important property. Then coming to fifth property, all properties are very important here. Fifth property, if x is a eigenvector, if x is a eigenvector of A, matrix A, then x is also eigenvector of A power of n. Just now only in the recent previous slide I explained this logic, the same logic. If x is a eigenvector of A, then x is also eigenvector of A power of n. Only lambda power changes. Very interesting. Sixth property, sum of the eigenvalues is equals to trace. There are so many get questions on this property, very important. Seventh property, product of eigenvalues is equals to determinant. Sum of the eigenvalues is trace, product of eigenvalues is determinant. Eighth property, eigenvalues of A and A transpose are same. Ninth property, one of the eigenvalue of singular matrix, is 0. So as all of you know, why one of the eigenvalue of the singular matrix is 0. What is the determinant of the singular matrix? Determinant of the singular matrix is a 0. So determinant is equals to what? Product of the eigenvalues. Product of the eigenvalues is the determinant. That's why one of the eigenvalue is 0 for a singular matrix. 10th property, all eigenvalues of non-singular matrix, are non-zeros. What is a non-singular matrix? Non-singular matrix means determinant not equal to 0. Singular matrix means determinant is 0. So when determinant is not equal to 0, if all eigenvalues are the non-zeros, if any eigenvalue is a 0, determinant is going to become a 0 using the property product of the eigenvalues is the determinant. So that is about the 10th property. Next, 11th property. All properties are very, very important. 11th property. Eigenvalues of triangular matrix. Eigenvalues of triangular matrix. Triangular matrix, diagonal matrix. Eigenvalues of triangular matrix, diagonal matrix, and scalar matrix. Eigenvalues of triangular, diagonal, and scalar matrix is equals to its principal diagonal elements. So principal diagonal elements, very, very important property. Principal diagonal elements. Eigenvalues of triangular, diagonal, scalar matrix are principal diagonal elements. 12th one. Eigenvalues of symmetric matrix and Hermitian matrix. Eigenvalues of symmetric matrix and Hermitian matrix are always real. This bit repeated 2 times in the GATE exam, direct bit. Eigenvalues of symmetric matrix are always real. Are always. Options they will give real, imaginary, like that, different. What is the answer? Always real is the correct answer. What is the condition for the symmetric matrix? All of you know A transpose is A. And Hermitian matrix condition is what? A theta is equals to A. Next, 13th property. Eigenvalues of skew symmetric matrix. Eigenvalues of skew symmetric matrix and skew Hermitian matrix. Eigenvalues of skew symmetric and skew Hermitian matrix are always either zeros or purely imaginary. Either zeros or purely imaginary. This is also previous GATE question, is also repeated 2 times. These two are very, very important. Straight bits, no need to do any mathematical. Eigenvalues of symmetric matrix are always real. Eigenvalues of skew symmetric matrix are always either zeros or purely imaginary. Symmetric and skew Hermitian matrix, both are, what is that? Either zeros or purely imaginary. That's very, very important point. Hope all of you understood. Next, 14th property. Yeah, I'm going to give one table here. 14th property. What is the 14th property? Very, very important. If lambda is one eigenvalue, of orthogonal matrix, if lambda is one eigenvalue of orthogonal matrix, then 1 by lambda is also another eigenvalue. 1 by lambda is also another eigenvalue. So why 1 by lambda is another eigenvalue? Remember that orthogonal matrix, what is the determinant of orthogonal matrix is plus or minus 1. Remember this. Yeah, to get that, with this formula is main concentration. If it is a 3 by 3 matrix, we have 2 is one eigenvalue. What are the other eigenvalues? 1 by 2, 1. Or 2 is one eigenvalue, other eigenvalue 1 by 2 minus 1. If 2 is another minus 1 by 2, 1. Like that, different combinations raises. Product of the eigenvalues is required. What determinant? It must be equal to plus or minus 1. Any plus 1 or minus 1, both are considered here. What is the product of these eigenvalues? Plus 1. What is the product of these eigenvalues? Minus 1. What is the product of these eigenvalues? Minus 1. So any combination like this you can take, but product of the eigenvalues, that is a determinant, it must be plus 1 or minus 1. That is also very very important property. 15th one, yeah, if you are taking 15th one, very very important and interesting. Yes, if lambda is eigenvalue of a, if lambda is eigenvalue of a, then lambda power of n is eigenvalue of, if lambda is eigenvalue of a, lambda power of n is eigenvalue of a power of n. Remember this, lambda power of n is eigenvalue of a power of n. 1 by lambda is eigenvalue of a power minus 1 inverse. K lambda is eigenvalue of ka, and same lambda is eigenvalue of a transpose. A and a transpose contain same eigenvalues. Then coming to next, determinant of a by lambda is eigenvalue of adjoint a. Determinant of a by lambda is eigenvalue of adjoint a. Then lambda plus or minus k, lambda plus or minus k is eigenvalue of a plus or minus ki. This table is very very important. So many gate questions on this table also. These are the 15 properties of eigenvalues and eigenvectors. All are very very important. So please concentrate. Yeah, try to remember all properties. So next questions on the eigenvalues and eigenvectors. Very very interesting questions. Let us solve some questions on eigenvalues and eigenvectors. Yes. One question here, first question on eigenvalues and eigenvectors. Let us take first question on eigenvalues and eigenvectors. All questions are very very important. So now you can solve all the questions here. Yeah, first question here. The eigenvalues of the matrix. Eigenvalues of the matrix 3, 4, minus 4, minus 5. Eigenvalues of the matrix 3, 4, minus 4, minus 5 are. So that is the question is given. What are the different options? Observe. Whenever you are solving questions on eigenvalues, eigenvectors, remember the answer is available in the options only, directly trial and error only. Most of the time go with the trial and error. 90% of the questions are trial and error. What are the options given? Minus 2, minus 2, plus 2, minus 2, minus 1, minus 1, plus 1, minus 1. See here, if you are having correct knowledge, perfect practice, 5 seconds enough to answer this question. 5 seconds. No need to go 2 minutes or 3 minutes. No need. 5 seconds enough. Whenever they are asking eigenvalues, no need to go with the determinant of a minus lambda equal to 0. So it takes lot of time to calculate determinant of a minus lambda equal to 0. It takes time. Instead of that, apply the properties enough. Anybody tell me what is the answer? 1 minute I will wait. Tell me what is the correct answer. A, B, C, D, which option? A, B, C, D, which option? Yes, apply the properties enough. Anybody? So what is the property I am going to apply here? Sum of the eigenvalues is trace. Sum of eigenvalues is equals to trace. So this property we are going to apply. Sum of eigenvalues is the trace. What is the trace of this matrix? Trace is means what? Sum of the principal diagonal elements. Trace is minus 2. Trace is minus 2. Now, which sum of the eigenvalues is minus 2? Now tell me. Now you can guess the answer. Which option is correct? A, B, C, D. Tell me now. Trace is minus 2. Sum of the eigenvalues is the trace. Which sum of the eigenvalues is the minus 2? A, B, C, D. Which option? No one is responding. Which option? Please confirm which option is correct. A, B, C, D. Sum of the eigenvalues is the trace. Okay, no problem. Which option here? It is the option C. What is the sum of these eigenvalues? Minus 1, minus 1. This is minus 4. Wrong. 0, 0. Only option C is the correct answer. Straight away, hardly 5 seconds enough to answer this question. Just go through that property. Sum of the eigenvalues is the trace. Yeah, next question. Eigenvalues of the matrix. In the previous gate papers, you will find so many questions from the eigenvalues and eigenvectors. 4 minus 2 minus 2 1. 4 minus 2 minus 2 1. Sum of the eigenvalues of the matrix 4 minus 2 minus 2 1. Option A 1 4. Option A 1 comma 4. Option B 1 comma 2. Option C 0 comma 5. Option D cannot be determined. Can't be determined. So 4 minus 2 minus 2 1. Can anybody guess? Yes, tell me what is the correct answer here. Anybody? Four minus 2 minus 2 1. Again, once again I am writing that matrix. 4 minus 2 minus 2 1. Yeah, tell me what is the answer correct. Which option? What is the trace here? Trace is equals to 5. Trace is 5 here. Sum of the trace means what? Sum of the principal diagonal elements. Trace is 5. Which sum of the eigenvalues? Which sum of the eigenvalues? Which sum of the eigenvalues is 5? 1 4 is 5. 0 5 also 5. Both are correct. So both are giving the 5 answer. 1 4 0 5 both are giving 5 answer. Sum of the eigenvalues is the trace. But which one is correct out of these two? Which is correct exactly? We have to go with another property. What is another property? Is determinant. What is the product of the eigenvalues is the determinant. What is the determinant of this one here? What is the determinant of this matrix? Determinant is equals to 4 minus 4, 0. Determinant is 0. Determinant is equals to what? Product of the eigenvalues. Determinant is equals to product of eigenvalues. Now which option is going to become correct here? Product of the eigenvalues must be 0. Option C is the correct answer. So two properties totally we are applying here. Two properties we are applying here. One is what? Sum of the eigenvalues is the trace. Product of the eigenvalues is the determinant. 0 5 is the correct answer. 1 4 is the wrong. So this is clear to all of you. Everybody understood. It's a very interesting question. Two properties I applied in this case. Right. Coming to our next question. So all questions are eigenvalues, eigenvectors, very important, definite type. Yeah, coming to our next question here. Eigenvalues of the matrix. Eigenvalues of 5 3 to 9. Eigenvalues of 5 3 to 9. What are the eigenvalues? Option A 5.1 to 9.42. Option B 9 comma 5. Option C 3.85, 2.93. Option D 10.16, 3.84. What is the correct answer? Eigenvalues of the matrix. So here I will wait 1 minute time. Tell me what is the correct answer. What are the eigenvalues of the matrix? What is the correct answer? See, sum of the eigenvalues is the trace here. What is the trace here? Trace is equals to 5 plus 9, 14. Which sum of the eigenvalues is 14? B and D. Both are satisfying. Check B and D. But we have to go with another property. What is another property? Product of eigenvalues. Product of eigenvalues is determinant. Product of eigenvalues. Product of eigenvalues is the determinant. What is the determinant of the matrix here? Determinant is what? 45. 45 minus 6. 39. 39. Whose product of eigenvalues is 39? If you take 9 into 5, it is a 45. It's not 39. B is wrong. Only D is the correct answer. D is only the correct answer. B is the wrong. So how many properties we are applying here? Two properties we are applying. Sum of the eigenvalues is the trace. Product of the eigenvalues is the determinant. That question is clear to all of you. Last question is clear. Any confusion, please clear. Hope everybody understood last question. Next. Eigenvalues of the matrix. Eigenvalues of the matrix 1, 2, 3, 1, 2, 3, 0, 4, 7, 0, 0, 3. So this is a matrix is given. Eigenvalues of the matrix are option A 1, 4, 3. Option B 3, 7, 3. Option C 7, 3, 2. D option 1, 2, 3. Yeah, what is the correct answer for this question? Yeah. See what type of square matrix is square matrix. What type of matrix it is? A upper triangular matrix. It is upper triangular matrix. It is upper triangular matrix. What are the eigenvalues of the upper triangular matrix? Eigenvalues are what? Eigenvalues are its principal diagonal elements. Principal diagonal elements. What are the principal diagonal elements? 1, 4, 3. 1, 4, 3. That is the correct answer. Option A is the correct answer. It's a previous gate question only. So, what are the principal diagonal elements here? 1, comma 4, comma 3. They are the eigenvalues. So, all of you are understanding. Any confusion? For upper triangular, lower triangular, scalar, diagonal matrix, what are the eigenvalues? They are principal diagonal elements. Next question. A is equals to 1, 1, 1, 1, 1, 1, 1, 1, 1. Eigenvalues are, what are the eigenvalues? Option A is given 0, 0, 0. Option B is given 0, 0, 3. Option C is 0, 0, 1. Option D is 1, 1, 1. So can you guess what is the answer? Which answer is going to become correct here? 1 1 1 1 1 1 1 1 1. It is a 3 by 3 matrix is given. What are the eigenvalues of this 3 by 3 matrix? Anybody, what is the answer? Which option? What is the trace? 1 1 1. Trace is the 3 here. In this case, trace is equals to 3. Which sum of the eigenvalues is the 3 here? B, D. If you observe B and D, sum of the eigenvalues is the 3. But determinant is what here? Determinant of A is 0. Determinant of A is 0. Determinant of A is equals to what? Product of the eigenvalues. B option is the correct answer. Straight away, B option is the correct answer. So what is the D option? D option, what is the product of the eigenvalues? 1. But what is the determinant of this matrix here? 0. All rows are the same. All rows are the same. What is the determinant value? 0. Option B is the correct answer. Hope everybody understood. No confusion. Still any confusion is there in the previous questions? Clear? Yeah. Coming to next question here. Eigenvalues of the matrix A is given 2 2 2. The eigenvalues of A are So can anybody guess what are the eigenvalues of A? Yes, tell me what are the eigenvalues of A? Option A is given 0 0 0. Option B is given 0 0 6. Option C is given here 2 2 2. D, none of this. Yeah, which option is correct here? Tell me what is the answer, correct answer? Anybody, please confirm what is the answer, which option? 0 0 0 0 0 6 2 2 2, none of this. For some of the students, favorite answer is none of these also, but here you check which is the answer correct. Right? So don't think that none of these is always correct answer. See, what is the trace here? Trace. Sum of the principal diagonal elements, trace. Trace is 6. Then, so B and C, both are giving the sum of the eigenvalues is a 6. But which is the correct answer? If you check the determinant value is 0, B answer is the correct answer. Determinant is 0, product of the eigenvalues also 0. Which option? Product of the eigenvalues is 0. B option is the correct answer. Yeah, this is clear to all of you. Still anybody is having confusion? Clear? Yes. So coming to our next question. Yeah. So consider a non-singular 2 by 2 matrix. Consider a non-singular 2 by 2 matrix. So with the trace of A is equals to 4, trace of A square is equals to 5, then determinant of A is equals to what? That is our question, very interesting question. What is determinant of A? So this type of questions also very important and interesting. Consider a non-singular 2 by 2 matrix. The trace of A is 4, trace of A square is 5, then determinant of A is what? Non-singular matrix means what? Eigenvalues are not equal to zeros. For 2 by 2 matrix, how many eigenvalues? For 2 by 2 matrix, lambda 1, lambda 2. Two eigenvalues, lambda 1, lambda 2 are possible. Two eigenvalues. Trace of A. What is the trace of A? Trace of A is equals to sum of the eigenvalues lambda 1 plus lambda 2 is 4. Then what are the eigenvalues? If lambda 1, lambda 2, lambda 1, lambda 2 are eigenvalues of A. So then what are the eigenvalues of A square? Eigenvalues of A square are lambda 1 square, lambda 2 square. Using the property lambda 1 square, lambda 2 square are the eigenvalues of A square. Then what is the trace of A square now? Trace of A square is lambda 1 square plus lambda 2 square. Trace of A square is lambda 1 square plus lambda 2 square is 5. These two are given. Lambda 1 plus lambda 2 is 4. Lambda 1 square plus lambda 2 square is 4 is given. From these two we have to calculate what is the determinant of A using these two. So now you take lambda 1 plus lambda 2 whole square. Lambda 1 plus lambda 2 whole square is equals to lambda 1 square, lambda 2 square plus 2 into lambda 1 lambda 2. So what is the lambda 1 plus lambda 2 here? Lambda 1 plus lambda 2 is 4. 4 square is 16 is equals to lambda 1 square plus lambda 2 square. Lambda 1 square plus lambda 2 square is 5 plus 2 into lambda 1 lambda 2. This 5 bring the other side. Then what is the lambda 1 and lambda 2, which is a product of eigenvalues is the determinant. How much is value? 16 minus 5, 11 by 2 is the answer. 11 by 2. So this type of questions also very interesting. So we should have the knowledge about what is the trace of E and eigenvalues, eigenvectors concepts to attempt this type of questions. Yeah. See here, if you are observing, see, so today in the beginning session, what is the topic we have discussed? It is a system of linear equations. What are the linear equations we have done? Homogeneous and non-homogeneous. Related to homogeneous, non-homogeneous, what is a consistent, inconsistent, trivial solution? What is the procedure to solve the homogeneous and non-homogeneous using rank approach we have done? So around 12-13 questions we have done. They are all very important and interesting. Then later characteristic matrix. What is the characteristic matrix? A minus lambda I. Characteristic equation, determinant of A minus lambda I equal to 0. The roots of characteristic equations are called eigenvalues. What is the eigenvector? Infinite number of non-trivial solution is called the eigenvector. Eigenvector is associated to what type of equations? Homogeneous equations. And remember all properties of eigenvalues and eigenvectors. So around 15-16 properties of eigenvalues and eigenvectors we have discussed. So very important, eigenvalues and eigenvectors properties also. So next question here, if you are observing next question here, sum of the eigenvalues is also previous gate. Sum of eigenvalues of the matrix. Sum of the eigenvalues of the matrix. The matrix is given like this: 215, 650, 725, 655, 150, 835, 485, 355, 550. What the question is asking? Sum of eigenvalues of the matrix. The options are given like this: 725. Option B is 915, 915. Option C is 530. D is none of this. What is the correct answer? It's a very interesting simple question. What is the property we have to use? Straight question. Sum of the eigenvalues is what? Sum of eigenvalues is equals to trace. Straight property. Sum of the eigenvalues is a trace. What is the trace of this matrix here? Sum of the principal diagonal elements. 215, 150, 550. Simplify this. 915 is the answer. 915 is the correct answer. Option B is the correct. So there is no need to go with the determinant of A minus lambda equal to 0. It takes lot of time to calculate what is called eigenvalues and their summation. Whenever they are asking sum of the eigenvalues, straight away the answer is the trace. Yeah. So we will solve some more questions on the eigenvalues and eigenvectors in tomorrow's session also. And what are the other topics left for tomorrow? It is a Cayley-Hamilton theorem. Cayley-Hamilton theorem. What is the statement? Every square matrix satisfies its own characteristic equation. And LU decomposition. Then linear dependent and independent of the vectors. After this one, eigenvalues and eigenvectors, next major topic is the Cayley-Hamilton theorem. And this LU decomposition, linear dependent and independent are the small topics. Okay, with this today we are going to close the session. Okay, all of you understood. Any confusion still? Go through that again videos, any confusion, and PDFs also. But definite type of questions are there from the eigenvalues, eigenvectors, homogeneous, non-homogeneous. So from the linear algebra, 2 to 3 marks definitely concentrate. Last year 2024 GATE CSC toppers and CSC DA DS batch all AML 90 plus marks they scored. Just you search in the Google what are the toppers marks in 2024. 90 plus marks means for out of 190 plus marks you understand what is the competition is there, how much competition is going, and especially CSC data science AML. If you are studying in the top IITs MTech, then only it is useful for good placements. Lower IITs again no use, lower NITs also no use. Only if you want MTech, only top IITs you have to concentrate. Like Bombay, Chennai. Chennai is the top number one. Chennai, Bombay, Delhi, like that. Kharagpur, Kanpur, IISc, Bangalore, and also Hyderabad also very good, no problem. You can select top IITs also, right? So thank you. 90 plus, you keep that in mind. Today's session we are going to close. We'll meet in tomorrow's session for the linear algebra. Thank you. Hope everybody understood.